We are going to continue our work with conditional statements, if-then statements, by taking a look at our B-4 notes. I can use the laws of detachment and syllogism. That's called syllogism. We'll get to that law. It's kind of a funny name. We'll get to that law here in a couple of minutes. We're going to look at if-then statements. We're going to talk about some of their properties and the two laws. And you will be using these laws. We're going to talk about deductive reasoning. We're getting closer to actually doing a proof, and we're going to be looking at deductive reasoning. And now we did inductive reasoning at the very beginning of the unit in B1, but deductive reasoning is thinking logically. So we're going to be using logic to think about statements, and we're going to start from a given set of information that's given to you, and by logically looking at that information, can we say other things have to be true? And we're going to work our way through statements that are given or facts that you can figure out all the way to a conclusion. And this is how we prove theorems and how we will do some proofs of certain things. So we'll use deductive reasoning, thinking logically from given statements or facts to a conclusion. All right, so now if we just simply want to look at some of these laws, this is just laws that will work with if-then statements. So the law of detachment basically means that if the hypothesis of a true conditional statement is true, then the conclusion is automatically true. So basically we talk about two things that are happening right here. So we start off by saying, here's a conditional statement. If there is lightning, then it's not safe to be out in the open. So that's a conditional statement. If you look, and this part's true, this part would be true. If you see lightning, then it's not safe to be out in the open. Now, the second part of this, the law of detachment part, basically is a second statement that basically says that the hypothesis is true. Mary sees lightning from the soccer field. Okay? So we know that the conditional statement is true, and then this statement sort of confirms that the hypothesis will be true. Mary sees lightning from the soccer field. So what can we conclude about that? Well, if Mary sees lightning from the soccer field, then we can assume that it's not safe to be out in the open, out by the soccer field. Okay, because the hypothesis is said to be true, then we can assume that it's not safe to be out in the open, or in this case, out by the soccer fields. And that's what the law of detachment is. Again, you've got an if-then statement, and then a second statement that makes the hypothesis a true statement, then the conclusion would be true. So, if there's lightning, then it's not safe to be out in the open is true, and Mary saw lightning in the soccer field, well then it's not safe to be out. Just like in the statement we had earlier, if it is sunny, then I'll ride my bike. Okay, if you saw George riding his bike, what can you assume? You can't assume anything because we didn't say anything about the weather, and the if-then statement would be, if it's sunny, then I can ride my bike. You have to make the initial statement the true statement. Okay, law of syllogism. Sometimes that's called the chain rule. It basically links two conditional statements together. So it connects two conditional statements together when the conclusion of one statement is the same as the hypothesis of the other statement. And here's an example of that. Two if-then statements here. If a whole number ends in 0, then it is divisible by 10. Second statement. If a number is divisible by 10, then it is also divisible by 5. Okay, so the chain rule connects these together because, see, we have the divisible by 10 is the conclusion, and down here, the divisible by 10 is the hypothesis. So, if a whole number ends in 0, then it's divisible by 10. It gets linked to this one. If a number is divisible by 10, then it's divisible by 5. Because the conclusion of number 1 is also the hypothesis of number 2, then here's what we can say. If a whole number ends in 0, then it is divisible by 5. You can sort of take out the red part that you see there and go with the original hypothesis and the final conclusion. All right? And you will see us use this rule in proofs. Okay, so one more time. Since the conclusion of the first statement is equal to the hypothesis of the second statement, then the original hypothesis and final conclusion can also be written as a third if-then statement. And there's your two laws in section B4.